So hello guys, welcome back to my channel, and today we'll be talking about Zscore and standard score. Last video we have talked about the range, interquartile range, and whisker plot, box plot. So if you have any doubt, then please ask me with the help of the comment section. I'll reply there. And today we'll talk about the Z-score. So let's start. So what is Z-score? So Z-score is directly related with standard deviation. So when I was talking about the variance and standard deviation, then I explained like variance or standard deviation are nothing but it tells the spread or variability of your data point with respect to the mean point, right? And that's where we calculated the standard deviation, like on an average, like how much your data points are varying with respect to the mean point. And there we talked about the how much, like how much distance your data points are varying. But we have not talked about like how many, right? When we talk about many, then it becomes very concrete, discrete level, right? So that's where Z-score comes in picture. So Z-score is the tells you like in terms of number of standard deviation. So how many standard deviation away your data points are with respect to mean point. And this we calculate with respect to all data points, right? So we calculate on an average standard deviation with respect to the mean point, and with the help of that, we calculate the Z-score. So Z-score is a quantifying measurement, right? So it quantify like how many standard deviation away your data points are with respect to the mean point. Okay. So based on that, it has a formula like x minus mu divided by x standard deviation. So like what is x minus mu? It tells you the distance of this data point from the mean point. And then if you want to quantify that with respect to the standard deviation, then you divide the standard deviation of the other data points. Then this will be the value of like number of standard deviation. Number of standard deviation. Right? So this is the formula basically. So Z-score, also known as standard score. Z-score tells you how many standard deviation away, above or below from the population mean or sample mean. If you are talking about sample, your data point is. Okay. So let's understand with the help of examples. Okay. Suppose we have player 1 and player 2 data available. Like so previous 7 matches scores are available for player 1 and previous 7 matches score are available for player 2 as well. Okay. So how to calculate the Z-score? So for that, as you see in the formula, we have the mean and standard deviation. So first of all, we calculate the mean value of the data point, and we also calculate the standard deviation of the data point. So that's why the mean value is 33.28 for this player 1, and standard deviation is 24.27. Okay. And similarly, we'll calculate the mean value of player 2 and standard deviation of player 2. So guys, here I'm not going to explain how to calculate the mean value and standard deviation. I have already recorded a video on the same. You can go to my YouTube channel and then you can find how to calculate mean and standard deviation. Okay. Here we are focusing on Z-score value. So now we got the mean value and standard deviation value. Then we calculate the Z-score for each data point. Okay. So if you focus on player 1, then for this 20 for this score, what is the Z-score? Like this is how. So if you define how many standard deviation away this score is with respect to the mean point. So that's what this means. So this score means x, that is 20 minus mean 33.28 divided by standard deviation. It comes around minus 0.5. It can be negative also, right? So towards the left of your mean value. Okay, left or you can say below, right, or you can say up, above, okay, upside, right? So this is how you calculate the Z value, and similarly you can calculate for all of these data points. So I'm not going to calculate for each and every data point. I have shown you for one data point. You can calculate. You can pause the video and then you can calculate for your understanding purpose. Okay. And similarly, we can calculate the Z-score for player 2 as well. So this is the like calculation part, like how to calculate. But guys, in my video, I also explain and try to help you understand like what is the significance of each and every concept. Until you don't understand the significance and why we use that one, then it becomes almost difficult to remember or memorize those concepts, right? So that's why let's understand like what is the significance of this Z-score with the help of one problem. So the problem is like suppose there are 3 players with different abilities. Okay, so first player has average score 80 and a standard deviation of 12. Second player has just a minute. Second player has an average score of 40 and a standard deviation of 20. Okay. And similarly, third player has an average score of 60 with a standard deviation of 15. Fine, guys. Now, in a particular practice session, the first player scores 90, second player scores 55, and third player scores 75. Hmm? Now I'm asking, can you tell me and explain also with the reasoning who has done better against his own track record? Hmm? So suppose like this JD score also can be helpful in understanding. Suppose one player is playing golf, one player is playing badminton, and one player is playing cricket match. Okay, and in different sports there is different scoring mechanism. Okay, so so that's why, like if you want to compare the better player in his own sport and in his own capabilities. Okay, then how you compare those three players, because every sport requires different level of capabilities and different level of skill set. Okay, so for example, if I want to say, okay, compare mangoes with apple in terms of sweetness or taste, so they both have different properties and their taste differ, right? So suppose I want to compare berry with apple. So apple has a sweetness and berry could be sour or sweet, both, right? So they have different properties, and based on their properties, we judge them. Okay, whether that is good berry or good apple or bad berry, right? So that's where, like, when we want to compare the different set of skill set, okay, when two entities are not on the same page, then how to compare them? So that's where we use Zscore. In more advanced concept, we use ANOVA also. That's where we do analysis of variance. So that also come in later stages. But today we are discussing Zscore. So that's a very basic concept, okay, but very impactful, okay. So let's come back to this problem again and how. So the problem is like how to identify which player has done better against his own track record. We want to compare ourselves, kind of, okay. So we'll solve this problem with the help of Zscore. So let's plot. Okay. So Zscore is related with the deviation, and the deviation is related with the variability. So that's where we plot this kind of bell kind of curve. Okay, so this is also known as like normal distribution or normal curve. In the next video, I'm going to explain these curves and plots also. Timing, okay, we are plotting. So this is for first player. So their standard deviation is 12 and mean value is 80. Okay, this is for first player, mu1. Okay, and then what is x1? So x1 we are asking like in that particular day he has scored 90. So that x1 is like in particular session, particular practice match, 90 is the score of that particular player one. Okay. And now similarly we'll plot the player two data as well. So his standard deviation is 20, mean score is 40, and on that particular day he scored 90. Similarly, player 3, his standard deviation is 15, mean score is 60, and he is scoring 75 on that particular session. And now we want to compare. So how will compare? So for that, we need to calculate the Z score. Okay. So how we calculate the Z score? We know the formula x minus mu divided by sigma. So what you need to do? So for example, for player 1, we have sigma value 12, mu value 80, and x value is 90. What you can do? 90 minus 80 divided by 12. So that will be the Z score for player 1, and for player 2, what will be Z score? 90 minus 40 divided by 20. And similarly for player 3, it will be 75 minus 60 divided by 15, the Z score value. Okay. And one more thing, guys, for Z score, like when we divide by sigma, okay, so kind of we are normalizing the value around standard deviation. Okay, so that's where when we are normalizing the value along standard deviation, then it is known as standardization of the values. And standardization, when you standardize the value, then your mean point becomes 0 and standard deviation becomes 1. Okay, so that we can compare in both sides. So that's where standard here standard deviation is 1 and mu is 0. So that's where we have standardized the value. And then if we calculate the Z score, so similar way for Z1, it will be 90 minus 80 divided by 12, and it will give you value of 0.83. Okay. And then if you calculate Z2, it will become 0.75. Okay. And Z3 will become 1. So Z3 like 75 minus 60, that is 15 divided by 15, it will become 1. Okay. Very easy to calculate. And now see what they are telling basically. So if you remember the standard deviation video, okay, so in the standard deviation I explained, okay, so on an average how much data points are varying with respect to the mean point. Okay, and when we talk about the sports, we talk about the reliability. Okay, So who will be the most reliable player whose variance is less, who is scoring near to his mean score in most of the matches. Okay, but another side of this thing is also like X factor. Okay, if you want to go with X factor, like if in one fine day he will score very high, or in one fine day he can score very low as well. Okay, so that's what is X factor tells. Okay, but in general we go with the reliability. So who will be more reliable player? Who score in most of the matches around his mean score, right? Now comes back to Z score. So that's why Z score is also related with the standard score, and that's why it is related with reliability. So whose Z score is less, okay, he is going to be more reliable player. Okay. But now we'll tell here we are comparing with respect to this mean point, that is mu is equal to 0. Okay. And if we are in right side, who is near to this like who is far from the mean score, means upper, above mean score. Okay, so Z3 like 1, so he is far from the mean score in above direction, in positive direction, means in that particular session he has scored way beyond from his mean score, means more than his mean score. Z1 is compared to Z3, he is more near to mean score, and Z2 very near to mean score in one side. Okay. So if you talk about one fine day in that particular session, so Z3 has performed better against his own track record. Okay. And then Z1 and then Z2. Okay. In that particular practice session. But if I convert this to the selection process, if a coach wants to select out of these three available players, then mostly he will go with more reliable player. If he is not going to choose the X factor, if he is choosing more reliable player, then who is more reliable player? Who is scoring near to the mean score? That way he will select Z2. Okay. If you want to select based on the on an average who is performing better. But if I question is like on that particular session who has done better, then whose Z score is more on right side compared to mean point. But if Z score like if negative, it is coming towards this side. Okay, then negative side is less, right? Then we'll say like who is like near to mu value, sigma value. Ultimately, whose Z score is more on that fine day, then he has performed better. Okay, because Z score can be negative, positive both. So positive are higher side, negative are lower side. Okay. In one particular fine day, whose Z score is more, he is more good, he has performed better in that fine day. But if we want to select in overall performance in his historical data, then whose Z score is near to sigma is equal to 1 or mean point, okay, then he will be more reliable, and then reliability point, who is closer to mean point, will select that. Okay, so that's the answer for this answer to this question. The Z3 will be Z3 has performed better on this particular practice session. So basically, guys, this is the significance of Z score. Okay, so I hope this is clear now. And then this comparison we will discuss in more detail in ANOVA, analysis of variance after hypothesis testing. Okay. So that's it about Z score, and this is also known as standard score, guys. Okay, so I hope now it is clear. So if you like my video, then please don't forget to like, subscribe, and share with your community. So thank you for watching.